Okay, Chapter 8 deals with properties of different types of polygons. And in the first section, we're looking at what do their angles add up to. And one thing that we know already, up in the top left here, we've got a triangle. We know that angles 1, 2, and 3, which we call the interior angles of the triangle, add up to 180 degrees. So I've started a chart here listing the number of sides, 3, and the interior angle sum. If we ever use the words angle sum and don't say interior, we mean interior. When we want the exterior angle sum, we'll be specific about that. Okay, so let's move on to 4 sides. Well, we don't have a rule for that guy, but like we've done in most of the class, we're going to try to reason what we don't know from what we do know. We know that triangles have 180 degrees for their 3 angles. So what the process is, we're going to draw a diagonal. A diagonal connects 2 non-consecutive vertices. If I call this A, B, C, D, if I start at D, the consecutive vertex going that way is A. The consecutive vertex going that way is C. D and B are not consecutive. They're not one after each other as you go around. Okay, when I've done that, notice that I've created 2 triangles. So when the number of sides is 4, I've got 2 triangles, each with 180 degrees, for a total of 360 degrees in every quadrilateral. A pentagon, that's 5 sides, I can do the same thing. Let's pick this vertex here and connect it to that vertex and that vertex. I've divided this into 3 triangles. So when I have 5 sides, I can get 3 triangles times 180, and that's 540 degrees. Okay, down here on my hexagon, if I go from the vertex A, B and F are consecutive vertices. They don't create diagonals, but I can draw a diagonal to C, to D, and to E. And now I've got 1, 2, 3, 4 triangles. So when there are 6 sides, I have 4 triangles times 180 equals 720. Okay, so what we're looking at is we're trying to see, can we get a pattern to give us a formula for any number of sides? So let's suppose we have n sides in our polygon. By the way, an n-sided polygon is called an n-gon, where n is just the number of sides. So if a polygon has 21 sides, we could call it a 21-gon. I mean, we don't want to have to memorize all these special names up beyond maybe 10 or 12. Okay, now what we want to look at is what's the relationship between the number of sides and the number of triangles. 3, 1, 4, 2, 5, 3, 6, 4. Well, think about it for a second. Pause it if you want here. The relationship is that the number of triangles is always 2 less than the number of sides. So if you have n sides, you're going to have n minus 2 triangles, each times 180 degrees. And that's how we get the angle sum for any number of sides. That's going to be our formula. Now you might wonder, why did I put this guy over here? Well, see, he's different from all the others. All of these polygons have the properties that no matter where I draw the diagonals, every diagonal lies inside the polygon. When the diagonals are on the inside, these polygons are called convex polygons. And that's the type that all of our formulas are going to be dealing with. This guy has the property that it has a diagonal on the outside. This is called a concave polygon. A diagonal is on the outside. All these other guys are called convex polygons. And unless you're told otherwise in this chapter, you'll be dealing with convex polygons. I notice we can't see that up there. These are all convex polygons. Okay, so we've developed a formula. and that is the angle sum, which means the interior angle sum of a convex n-gon is n minus 2 times 180. Let's use that and solve a problem or two. So, the interior angle sum of an n-gon is the number of sides minus 2 times 180. Okay, so for example, we might have a problem that says, find the angle sum of a convex decagon. Now, a decagon, you'll learn in this chapter, has 10 sides. Well, if it has 10 sides, then what we're telling you is that n in that formula is 10. So, the answer is 10 minus 2 times 180. And that's 8 times 180, we get 1,440. All the interior angles together add up to 1,440. Now, what if we wanted to know what the interior angles were, each one, if the polygon had all interior angles the same? Well, the type of polygon that has all interior angles the same and all sides the same is called a regular polygon. So a definition here is a regular polygon is a polygon with two properties. One, all sides congruent, and all angles congruent. And you might have noticed that a triangle has as many sides as it does angles, and that's true for every polygon. So let's see if this polygon here was regular. And we wanted to know the measure of each of its angles. Let me see, I'm running out of space here. I'm going to lose my definition here. Hopefully you've got it now. And let's just continue this question. Find the measure of each interior angle of our regular decagon up here. A regular decagon. Well, our answer, we already know what all of the angles add up to. They add up to 1440. So if we simply divide that by the number of angles, which is the same as the number of sides, 10, we'll get our answer, 144 degrees. Again, what we would like to do if we can is to try to generalize that. And what we want to do is make some rules here then for regular polygons. So I'm going to leave a little space here because I want to talk about something called an exterior sum in a second. But if for a regular polygon, and again we're talking about an n-gon, n sides, n angles, the measure of each interior angle is equal to its interior sum, which is n minus 2 times 180, divided by the number of angles that it has, which is n. Okay. Well, I think I'm going to put in another video how we prove our next fact, but I'm just going to give the fact to you, and it's our easiest fact of the chapter. We've got something called an exterior angle sum, which means if I would have, say, any polygon, I've got a pentagon there, if I would add one exterior angle at each vertex, then I would have as many exterior angles as I have interior angles. And the exterior angle sum means to add up, in this case, 1, 2, 3, 4, 5 exterior angles. We'll prove this in class, but it's a neat little fact. No matter how many sides you have, the exterior angle sum is always 360 degrees. That means that for a regular polygon, a regular n-gon, that the measure of each exterior angle is just 360 divided by the number of sides, which also equals the number of angles. Really easy formula to use. So, suppose you had a regular 22-gon. Polygon with 22 sides, all of them the same, 22 angles, all of them the same. And we wanted you to find the measure of each interior angle and each exterior angle. Well, because that's such a simple formula, that's what we're going to use first. Let's go find the exterior. The measure of an exterior angle is just 360 divided by, and I'm going to cheat so I can do this in my head. I'm going to make this a 20-gon. 360 divided by the number of sides 20. Each exterior angle is 18 degrees. Now, I could use this formula over here for the interiors, but there's a much easier way. Remember when we were drawing the polygons, here was an interior angle. Right next to it would be the exterior angle created by extending a side. Well, they're linear pairs. They add up to 180. So along with this stuff, just recall that the measure of an interior angle plus the measure of an exterior angle always has to add up to 180 because they form a linear pair. So if I've got that guy, that means the measure of the interior angle is going to be 180 minus 18. Each interior angle is 162 degrees, and I never had to use that formula, which is a little more complicated to begin with. Okay, so these are all of our big facts for section 8.1. There's one other type of problem that I'd like to put up for 8.1. We'll leave our rules over there. Actually, we won't, because I only need one of them anyway. Suppose we had a picture that looked like this. We've got this four-sided figure. So in terms of an n-gon, it's called a quadrilateral. The number of sides is 4. So its interior angle sum, we already said is 4 minus 2 times 180 is 360. So suppose the diagram looked like this. This is 2x. This is, it'll also be, it can't be that. If that's 2x, it's a bigger angle. We'll make this 2x plus 10. This is a smaller angle than 2x. Maybe we'll make it 3x minus 40. And this guy can be the biggest angle. We'll just make him 3x. Don't know how this is going to work out, but we're going to get an answer. Okay, we're going to solve for x and therefore get all the angles by using the fact that all the angles add up to 360. That's what angle sum means. So we've got that 2x plus 2x plus 10 plus 3x plus 3x minus 40 equals 360. And you'll see some problems like this in the book. You just want to find the angle sum for whatever you're working with, add them all up, add all the angles up and set it equal to the angle sum. So that's 2, 4, 10x minus 30, 10 minus 40, equals 360. So that would be 10x equaling 390, x equals 39. So you could find the measures of your angles. 2 times 39 makes that guy 78. This would be 78 plus 10 would be 88. This guy would be 3 times 39. That's 90, and 27 is 117. 117 minus 40 would be 77 degrees, and you've got all the angles there. Well, you ought to be prepared to do anything that's in section 8.1 now.